So the first part of this lecture will be about urban fabrics and the land use transport cycle. So this is this part of the lecture will try to connect what I know about transport, so movement, and how cities are built on a pretty big scale. So we'll start with the assignment, right? The assignment for this course, the 30-minute city. And I sent you this link earlier. These things are called isochrones. So if you plug in where you are and then plug in how much time you have to travel, this will show you this area where you can get to, right? Where you can get to by car, where you can get to by transit, and where you can get to by bike. And that's a way to visualize a 30-minute city. Because what I think is cool is that a 30-minute city is different depending on how you get around, right? So first task is, what do I mean by 30-minute city? And encourage you to explore that, right? Visually, and then I'll go into some theories about how you can think about a 30-minute city. But this is the first thing. Do it, play with it, and you know, get a sense. And think about your daily life. What is a 30-minute city to you, right? For Amsterdam, which is the topic of the assignment, this is the map I plugged in Central Station, and 30 minutes, right? So where can you get to? You see 30 minutes by transit. So this is a very transit particular map, and that's why you have these blotches, right? What are these blotches? Yes. And what type of, so there's a blotch here, and a blotch here, and a blotch here, smaller blotches here. What do you think the size of the blotches mean? So we got that they're around train stations. What does it mean? The size.
I don't think the size had a specific meaning. It wasn't just like the area you can get from to the middle of the city.
That's correct. So you have 30 minutes. This is your, I'm going to move into the economics part, okay? 30 minutes, think of this, the particular term is, okay, I'll get chalk later. So the particular term is travel time budget, right? So if we're talking about 30 minutes, then the 2 minutes it takes you to the walk to the station, you're down to 28, right? Get on an intercity train to Haarlem. How many minutes is that? Like 15, okay? So 2 plus 15, now you're down to 13 minutes. And so once you get to Haarlem, you have 13 minutes left. What does this blotch mean? What does the size of the blob mean? Yeah? Right?
Yeah.
Why is this blob bigger than that blob? It's more people. So you're starting from here. You don't need the train journey. So what does this mean?
Density of people.
Density of people, where you can get to transit services. Okay, so this represents, in a way, Jarrett Walker is a researcher that does transit, and this is kind of a map of freedom, right? You can think of it that way, a map of physical freedom. And the map will change depending on whether it's for a car, for a bike, for walking, okay? For walking, your possibilities are, you can check it out on this map when you go on the internet, drastically reduced. So, how have urban planners thought about this problem? Anyone heard of Howard and the Garden Cities? Yeah? Okay. So I think what's interesting here is we have this map of blobs of possibilities connected by rail stations, right? See some semblance of similarity to this ideal map and the one we had before? So you start at a central city, and this is one possibility of how you can structure a 30-minute city, correct? So I'll show you what these are. You can check this out on the internet. Just Google southern cities, Howard. And these are railroads. So this is 1900, right? So cars were not around, which is really interesting. So you had walking, you had horses, you had the railroad. So railroad connection, and then you had, ideally, he said, garden suburbs. And I think, don't quote me on this, but as far as I've read and I know, is that Dutch planners were quite inspired by this model. So this is 1900, and if you look at a map of the Netherlands, I think Peter van Weesenel, when he gives his lecture later, he'll touch on this a bit more. When you look at the map of the Netherlands, you can see it being inspired by this, right? Any of you been to one of the new cities, Houten, or what's another new Dutch city they built in the 70s? No, okay. So you'll see this pattern of development where they'll build this rail station, and then they'll build a new city around it. It's really cool. So we went from a practical example to more of a designer example. I'm really trying to appeal to the designers in this room, right? And then this is a zoomed in example, right? So we're gonna take one portion of this pie and enlarge it, right? Same thing, railroads, like a highway or something, a central city connected to, if we can call them suburbs, we can call them small towns. Do you kind of see the 30-minute city taking place in here? This is a possible way to do the 30-minute city. This is a possible way to do the 30-minute city before the car was invented, right? Okay, now I'm going to try and get more into the theory, because hopefully you'll be intrigued by what this all means and how do we translate this into research, right? We'll start with the history. So on this map, it plots a walking city fabric, it plots a transit city fabric, and it plots a car city fabric, right? What do you see? Observations.
Car gets the most mobility.
Car gets the most mobility. What else do you see?
They sort of overlap with the patterns.
Yes. And do you see a familiar pattern that's coming back from before? From the previous two slides? Yeah.
Little blobs.
Little blobs, right? And what do those little blobs, what do you think they are?
I imagine that's the walking
Yeah.
of, like, to a point of like, changing transit types.
Mm-hmm. Right? So this is researchers taking observation and thinking of a theory behind it, right? So that's exactly correct. The theory here is you move from the central city and take the transit urban fabric, and the little blobs represent how far you can get by train to another train station, right? And then the little blobs represent how far you could possibly walk to get from the train station to your house, right? We can easily adjust this. So imagine a world where instead of the 30-minute city, you were trying to design the 45-minute city. So we'll take apart fabrics one by one. So if we were to design, let's go from 30 to an hour, okay? So you double your travel time budget. What happens to each of these fabrics? We'll start with walking. So you're walking from the city center. What would you imagine to happen? Yes, the circle gets bigger, right? Because you can walk for longer. So instead of 2.5 kilometer radius, now you have a 5 kilometer radius, right? What happens to the transit fabric?
We have some extra nodes.
Extra nodes, and what happens to the nodes themselves?
Bigger as well.
They get bigger, yeah. Right? And then for the car fabric, which is this light colored thing out here, what do you imagine happens to that?
The entire screen.
Fills the entire screen, yeah. So, this is a theory, and you can play with this by using that website, right? So you can try 30 minutes in Amsterdam, double the travel time, click on each of the modes again, and voila, check if this is correct, if this is applicable, right? Some researcher came up with this. You can now use data to see whether theory matches with reality. And then if you sufficiently believe that this theory does match with reality, cite these guys in your paper, right? And that's how you get started with research. It's pretty simple on this level. Okay, so I'm going to dig in. So this is a very, I guess, designer way taking urban forms and extracting it. I want to get more into the theory and think about other ways to think about the 30-minute city. We're going designer, and now I want to think about space, but I want to graph it. Okay, why do these things happen? Why do we have the blob structure that we do? One explanation is travel time, but I also think, you know, and travel time, you are urban designers, I want to link this to land use, right? So how does travel time and the ways we get around relate to the built environment, which is what you do, right? You do it at individual buildings if you're architects, and you do it as a neighborhood if you're urban designers. Correct? Okay. So let's start with observation. What do you notice in city centers? It doesn't have to be a Dutch example. It can be from anywhere. What usually happens in city centers? Shopping. What do you notice about the type of land use? Like density, like how it's built, the built form? More dense. That is high rise, Why? Isn't that weird? Like why? Why can't cities just be flat?
Travel time.
Travel time. Boom. Is it kind of coming together? Okay. So how do we technically explain this? This is fun. No? Okay. How do we technically explain this? Why are buildings bigger in the city center? Why are they taller?
You can get more people to do the same thing or different things in the same place.
More people to the same thing.
Because the prices are, you only get the most out of it.
Yes, and the prices are high, right? So, and then you want to build up because the prices are high, because it's close to, in the Dutch case, a train station, because people like being close to the train station, or other businesses in general. You mentioned land use, like why is it retail and usually businesses and not residential, right? Because retail and businesses can afford higher prices, and because they place a higher value on dense land, right? Think of your business and your IBM or whatever, Google, Apple, and you want to have your employees closer to other services that they need, right? So if you want to mail something to another office, say you're a law firm, you want to courier something, and your clients are all businesses in the city center, then it makes sense to be by the businesses you are. And since you're a law firm, you make a lot of money, you can afford a lot of rent. And what happens if you have a big company that can pay a lot of rent for a place? What happens to the other uses who cannot afford this rent? They leave, right? They leave, they get edged out. So what remains are only the people who can afford to be close to other people. The size of the buildings go up in response to this. you see how a city is starting to form? Right, and it's close to the train station, so now the 5 minutes you take to walk to the train station, more people can get to the train station because more people are living in closer together, and you have access to other people. That's what cities are, right? Cities are, they're built, yes, but the reason why they're built is so you can be close to other people. Otherwise, people can live on the farm, right? This is, and then to be close to other people, now we're talking about mobility and transport. Right? They build an intercity line, it's like magic. Boom, we turned your 5-hour walk into a 30-minute train ride. So you're geographically far apart, but temporally, technology brings you closer. So that's this map. And then this map tries to explain this with prices, right? So like you said, the businesses come, they edge people out. So residents still want to be close to where they work, right? You still want to be close to your office, but whoops, you can't afford the city center because you've got all these retail and offices there. Right, so now this is the price of land. This is called the bid rent theory. You can Google this if you want to learn more. And you have the CBD, it's a central business district. It's like a pretty American term here. You have a central retail thing, right, like a pedestrian zone. Basically the center of the city, whatever form that takes. And you have the distance on the x-axis. So this is a very simplified theoretical model, like it's blah, blah, blah. So as you get further from the city center, the price of land decreases. Makes sense, given that what we talked about? Is this do you buy this argument? It could work, right? This argument could, in general, it could work. Now, tell me about some exceptions to this. Some of you aren't buying this, so like, in what cases does it not work? Because it's a straight line down. The price of land is not a straight line down. You can find expensive apartments slightly further away from the city, slightly closer. So clearly there's some exception to this rule, right? And this is where we bring in the little circles and travel times back in. Right, so do you kind of recognize this thing down here? Right, so this thing down here was kind of resembles the isochrone map that I showed you in the first, where 30-minute travel time, and then we theorized it into little blobs on a page and by travel mode, and now I'm using this layer on the bottom, but you can recognize where this is from now, right? Why there's a blob structure, central city, outer suburbs, okay? And then superimposed on top of this is rent, so the price of land. And this is how you can kind of picture the exceptions, right? A, central business district, so that's the center of the city, rent is really high, and then D is a subcenter, and E is like the yellow spots, suburbia. So it's possible that as you move out, there's a subcenter. What's a good example in Eindhoven? What would be a subcenter? Think of a place. Straight Best, yeah, that could be a subcenter. Pretty hip and popular place to live. Right? So this is putting, the financial and economics layers. We have the time, we have the location, we have how this relates to the economy and how land values work, right? And then with this knowledge is individual architects, right? You can see like where you can make your money as builders. It might not always match up in reality, but in general, if you build a tall building next to a train station with frequent service, like you're probably gonna be able to charge high rents for it, right? So you don't have to be an urbanist to just benefit from knowing a bit about the city. So here we go. So this is now, we're gonna take all that and think about it as interactions, okay? So because land use and transport not independent of each other, as we've just established. If you change the way you move around, you unlock new possibilities for land use, right? And by unlocking new possibilities for land use, based on what you said about the activities, the commerce and businesses and how that changes, then you change activity patterns. So where do people go? You change that too, right? Like maybe the center of Eindhoven was, when it was a small village, only people lived there, right? And now there's a lot of commerce and businesses and stores. So you change the activity patterns, and then accessibility is when you change transport, you change how far you can travel within a given amount of time. More things become accessible or less. And then if you change the density of the things you build, so you build higher up, right? Instead of walking 15 minutes, now you can take elevator from floor 1 to floor 99, zip, you're there. So it changes how people move about, and it changes the mode that's available to give you this accessibility, right? So a consequence, for example, city centers, difficult if you're driving a car. Correct? Right? No place to park, really expensive to park a car. People don't like that, you know, they want to be able to park everywhere for free, and we'll get into that later, but as a result of expensive parking, you're unlocking all these uses, right? So instead of a parking spot, you can instead build a store or build something for bike parking. So this will tie in later, you know, when I talk about why do we need to get away from the automobile system, right? Like, why not pile up cars in the center of our cities? Why not? Okay? And then this is visualized. All of this comes together in some kind of this way. So we went from a real city, right? I started Amsterdam, and very practically how far can you travel? And here is where you can think of it more conceptually. Right? And this is like the leap you kind of want to do to be able to generalize a specific problem and make it applicable anywhere, theoretically. Okay, so up here, land use. Down here, the transport network. And then in the middle is spatial interaction. So how do these two interact, right? This is a visual way of kind of putting this cycle or interactions into practice. Any questions following so far? Interesting thoughts? Did I lose you anywhere? No? Okay. All right, here we go next. So this is it. This is it for the first part. Yeah? Let me see if I missed anything. No, got it all. That map. And that's why I was so excited to find this, and I shared the link with all of you. I'm like, go play with this, right? Go play with this. Because with this map and with technology, right, you just plug in the numbers, and you can see all of this. You can see what I've just told you. And if you don't see it, maybe the theory is wrong. I don't know, right? But for me, the theory is like, you're buying my arguments, it seems generally okay. It seems like a reasonable thing to think, a way to think about the world. That's pretty cool, right? To be able to turn something like this, a map of the world as it is, into a theory of the world as it conceptually could be. So, I think the takeaway for architects, right? This is when you start your own firm, you know, think about, right, you're trying to make money, you're trying to build a big building, you're trying to make money, you want people to pay a lot of rent for your building, right? Like this is, I guess this is how you could think about it. Look around, I mean, I walk around cities and I think about how it kind of fits in here. And the things, the more interestingly, is walk around the city and see where things don't fit. And think about why they don't fit, right? Because this seems reasonable, but later on, it's a what's missing here? What's missing in this map we got? Walking, transit, auto. What's missing? What is the coolest thing about the Netherlands?
Bike.
Bike. Right? Right? It's missing. It's missing. Where's the bikes? 27% of Dutch people ride bikes. Dutch people ride. 27% of their trips are made by bicycles. 27% of all trips, right? Now you can see what's missing here.